We used to think the Earth was all that there is, and then we built telescopes and we could see a bit further, and we realized, oh, there's other planets, and eventually we realized that those planets orbit around the sun and there are other suns. And so there's this evolving hierarchical picture of structure in the universe, and it seems that it just gets bigger the better we can look out. The multiverse is, as it says, a collection of universes. The theory of inflation predicts, in a sense, that there's a multiverse. Inflation is this period of accelerated expansion that we think happened in the early universe. This is happening in the first 10 to the minus 30-some seconds. And during that tiny amount of time, the universe grows from something much smaller than an atom to something as big as galaxies. There are these fluctuations during inflation of the field, so space is ripping apart so fast that it just excites space-time itself. You can't do it without making space-time a little bit crinkly. And those crinkles turn into galaxies and all the nice structure that we see in the universe today. But you have to be a little bit careful, because it turns out that once you get inflation started, it can be really difficult to make it stop. And that's this idea of eternal inflation. So here behind me you see the multiverse, okay? So this is a picture of eternal inflation. And what's going on is you have this medium that's filled with this substance, often called the inflaton, that doesn't dilute as the universe expands. It's got a constant energy everywhere, and so it's causing the universe to undergo accelerated expansion. Once these bubbles form, they grow, but as they grow, they're also getting ripped apart from each other by the expansion of space. And the idea is that somewhere in that mess of bubbles, you'll find a bubble that contains our universe. Let's say we live in one of these bubbles. Just the fact that we're in this turbulent, expanding sea and the bubble is not totally left alone, it's getting buffeted by all these waves, that'll show up as very, very long variations in the CMB. If we run into another pocket, then that would actually show up as a fairly dramatic bruise in the CMB. If I were to look at this light in different directions, then I would see some disk in the sky where the intensity of the light is a little bit different. If you wanted to go out and test this idea, then one way to do that is to go look for these bruises in this light from the early universe. You just simulate that very early time of inflation. Okay, so you're simulating the first 10 to the minus 30-something seconds of the universe. The bruise that collision leaves is imprinted on the density in the very early universe. And so you can turn that imprint on the density into a prediction for what we actually see on the sky. And then I can compare what I get to what we see in real life. It's counterintuitive in the same sense that quantum mechanics is. Laws of nature on the very smallest scales don't act like the laws that we see on the scales of humans. The universe at very early times and the universe on very large scales does not necessarily need to behave like the stuff we see around us on the Earth. If there are other bubble universes, as Alan Guth likes to say, anything that can happen will happen, and it will happen an infinite number of times. The fact that it's not necessarily possible to see the entire multiverse and probe it experimentally has led people to say that this idea is not a scientific idea, right? This is not science, it's philosophy, and so what if there's other universes? If I can't test the idea, then what's the point of talking about it? So I think a very nice part of this work, even if we don't find any evidence for other universes, is that it shows that there are indeed predictions that can be tested with experiment that come from this idea of the multiverse. While it's certainly true that there are versions of the multiverse that actually don't give predictions for experiments, saying this idea makes no sense and is not science as a blanket statement, I think is just not right. I mean, there are models that can be falsified, And that's really the mark of a scientific theory. And I think that's a really important step in the right direction for putting this idea of the multiverse on scientific footing.